determine if B, a vector, is a linear combination of the vectors a1, a2 and a3. That means, can we find scalars or constants c1, c2 and c3 so that B equals c1 a1 plus c2 a2 plus c3 a3. So let me write that here. So from this equation we want to find c1, c2, c3 if possible. If we are able to find the values, then yes, B is a linear combination, otherwise no. So this vector equation, instead of writing these vectors, I am just using a1, a2, a3 for now. This is same as if we leave a1 vector is one column, a2 vector and a3 vector, okay, and I'm making this as a row. In fact, this is a 3 by 3 matrix because a1 itself is 3, it's got 3 members, okay, times, now I want to write in this way, c1, c2, c3. Okay, if we multiply, we're gonna get this. Is that equals B? Okay, and that translates into a system of equations. In fact, if we expand this, and from there we can write the following augmented matrix, just these vectors and B. So let me write a1, which is from here 1, negative 2, 2, a2 is 0, 5, 5, a3 is 2, 0, 8, and the constants, this is B, that goes in the fourth column. B is negative 5, 11, negative 7. So this is the augmented matrix coming from this system, and the first column refers to C1 when we solve. So we're going to get C1, C2, C3. So let's put this in row echelon form. Okay, so this is 1, so we're going to make this 0. So that means we need to work on R2. So we need to work on R2. So R2 plus 2R1. So if I multiply by 2, 2 minus 2, 0. In the same way we can make R3 0, the first element, okay, A3 1, this is R3. So R3 plus, we need to multiply by negative 2R1. So we are not doing anything to R1. So let me do that. So we get this matrix. Next, let's make this 0, 0, this 0. We can make this 1 first if we like, but same thing, we can make this 0. Now here is 5. So R3, we're going to work on R3. So R3 plus negative 1 times R2. If I multiply this by negative 1, this becomes negative 5. 5 plus negative 5 is 0. So we are only working on R3. So R1 and R2 stay same. Okay, so only R3 is being changed. So we get this 5 minus 5, 0, 0. 3 plus negative 1 is just 2. Okay, and look at this third equation. So we are getting 0, 0, 0 equals 2. Okay, pretty much 0 equals 2. That is coming from the third, and this is not true. Okay, this is false. That means what we tried to write here, okay, is not true. Okay, we cannot write in this way. So the way we tried here, this is not true. So this is not true. That means no, B cannot be written as a linear combination of these three vectors. Okay, so no, B can't be written as a linear combination of A1, A2 and A3. Okay, that's the answer.